Okay, so histograms are going to show you be symmetric, skewed to the right, skewed to the left. Box plots can show you the same thing, but box plots they tend to look a little different. But I want you to think about, when you think about how is the box plot skewed, how is it symmetric, you need to think about how would it look in a histogram. And this is one of a common question. They'll ask you to match a histogram to a box plot or a box plot to a histogram. So, symmetric. It is going to be right and left sides of the histogram are approximately mirror images of each other. Symmetrical, roughly. So if the questions, if you have a distribution and you always talk about a distribution, shape, center, spread, talk about those gaps, and you get a histogram that looks like this, you've made one, you would say the distribution of, let's say we were talking about heights. The distribution of height is approximately symmetrical with the center in this. And the spread, and right now we're going to talk about the spread from the smallest to the largest. When we start talking about standard deviations, we'll use that as our spread. But you guys, if it gives you nothing but a histogram, and it says, please describe the distribution, those things you're not going to be able to find. You're just going to describe it. Shape, center, spread, gaps, and clusters. Those are the 5 things that you need to talk about. Some people call them gaps, okay? They call it socks. Shape, center, spread, outliers, stuff like that, and we'll talk about that. Okay, so that is approximately symmetrical. Skewed to the right. The tail is in the right. What you need to know, though, is most of the data is on the left. The reason it is called skewed to the right is because that tail end is pulling the data towards it. I'm showing you, but they can't see me. So that's the one thing you need to know, is that when you're looking at a histogram, and you need to look at where the tail is, because that tells you which way it's skewed. If it's skewed to the right or to the left. It's not where the data is, okay? So if you look at your foot, you take your shoe off and you look at your foot, your right foot is skewed to the right, your left foot is skewed to the left. Because if you think about your foot, right, your big toe and it slants down, your big toe and it slants down. Wherever the tail is how it's skewed, okay? So let's draw a graph. Let's draw a graph. That's a really small bar. They should all, remember what on the other page I told you that they should be the same width? Yeah, those, not good. They're not the same width. They should be, this bar should be the same width as that bar. Okay, so look, you can see that it's skewed whoop, to the right. You can see there's a gap, but that's skewed to the right. Notice, see how the tail is gonna be. So you guys, that tail is gonna pull everything towards it. That's why it's skewed to the right, because it's gonna bring up certain measures towards that tail. Okay. We're gonna go with skew to the left now. So skew to the left, where's the tail gonna be? Yep. What is that word? I don't even know what that word is. Oh my God. The tail is in the left. Okay. And where's most of the data at? Yes. Did you guys even notice that I wrote date here instead of data? Most of the data, I bet you e-learners caught that. I bet you e-learners caught that. I met 5 of my e-learners yesterday. We had a Teams meeting. It was really cool. Most of the data is on the left.
You mean right?
Crap! You guys are gonna need a whiteout, some type of whiteout at home. Okay, there we go. At least yours is gonna be neat. On the right, okay. So now we're gonna go backwards. I was just having so much fun. There you go. Okay, so what I'm going to do, and you guys, the same thing goes for a dot plot, for a stem plot. A stem plot, you can actually take and change it, and it will look like, once we do a stem plot, it will actually look like a histogram. Like you can make a stem plot look like a histogram. It's kind of cool. So we have symmetric, we have skewed to the right, we have skewed to the left. So what we are going to do now is we're going to look at this, check your understanding. Can you guys see that? And it's been 10 minutes, right? Okay, so you guys at home, I want you to do this problem. Hey, you guys that are sitting in class, I want you to do this problem. So we're all doing it together. Look, we're all one big happy stats family. But I'm shutting you guys off. Hybrid A, e-learning students, you do it on. The next time I'll turn it on, you'll be there. Okay, peace out.